The IPv6 protocol. IPv6 uses hexadecimal numbering, and it's represented with that OX at the front. Some examples are 4 bits are combined into a hexadecimal number. As you can see, the 0, 1, 2, 3, 4, 5, 6, 7 representation. And then coming over here, you can see the 8, 9, and then for 10, 11, 12, 13, these numbers we have A, B, C, D, E, and F used as their representation. Changing the binary numbers to hexadecimal numbers are what you see right here. Also looking into the decimal number representation, you can see these numbers and these numbers right here. These are equivalent. The binary format, the hexadecimal format that has the OX, and then the blue letters are what we have our regular decimal number representation. In a counting sequence, in hexadecimal numbers, you will see 0 through all the way to F, listed as below. The IPv6 packet header contains all required functionalities to deliver an IPv6 packet to its destination, and that's why it's a datagram. The first field is the version field, and it includes the number in binary 6 listed over there, and that's because it's an IPv6 packet. The DS and ECN fields are 1 byte, and the DS is the differentiated service field, which comes first. It is the first 6 bits, and it distinguishes service priority assignments. The ECN bit, these 2 bits are the explicit congestion notification, and they are used for explicit signaling of congestion in the network to slow down the speed of packets that are being transmitted. The flow label was originally created to provide special services to support real-time applications. However, it is currently used to inform routers and switches to not change the routing path because the reordering of the packets will be difficult at the receiver. The payload length field indicates the size of the payload in octets, and it includes the extension headers. The maximum payload size is a size that is representable using the 16 bits of the payload length field. So therefore, it is 2 to the power of 16 minus 1, which equals 65,535 octets. A much larger size of an IPv6 packet can be supported under the IPv6 jumbogram protocol. A size that is 2 to the power of 32 minus 1 octets, which is a very large size. It is approximately like a 4 gigabyte file size for one IPv6 packet. It provides enhanced performance over networks that can support jumbograms. In addition, when you use an IPv6 jumbogram packet, you need to use the jumbogram, the jumbo payload option extension header. The next header field is 8 bits, and it specifies the type of the next header. Some of the options are TCP and UDP. In addition, it includes the others like ICMP, ENCAP, OSPF, and various others do exist. The extension header, well, it can be used, multiple extension headers can be added to the IPv6 header. You can add them on and use them to create the functionality within the network that you want. Each extension header has a different format, but most of them follow the TLV format, which is the type length value, which may include padding as well. The extension header options are listed here, and there's many more. Among these, the ESP, which is the encapsulating security payload, and also the AH, the authentication header. These are used for IPv6 security. The hop limit is 8 bits, and this is decreased by 1 at each intermediate node that the packet passes through. The packet will be discarded when this field becomes all 0. The source and destination addresses are this field right here. They are each 128 bits. Now, the CIDR notation is used to represent these addresses. An IPv6 address is 128 bits. and we can represent it as 8 groups of 16 bits. The 16 bits are 4 hexadecimal digits. So therefore, the address representation can be 8 groups with 4 hexadecimal digits, and 4 bits are represented for each hexadecimal representation. Once again, to review, the binary to the hexadecimal number to the decimal number are represented at the bottom. For an example IP address, IPv6 address is shown here, where you can see we use the colon to separate 8 groups, and in each group there are 4 hexadecimal numbers represented. Each hexadecimal number is 4 bits in binary, so therefore between each colon we have 16 bits. Now, the address representation follows these 2 additional rules. Zeros in front of the 4 hexadecimal digits can be omitted. 1 or more consecutive groups of zeros may be replaced with 2 consecutive colons. But you can use this only once in an IPv6 address. For example, look at this address, where on the left side, the second group has 05B8, and there's a 0 in front. On the 7th group, you see that there is a 03A and a 0, where a 0 is in front. So these 2 zeros can be erased, where the 0 in front of the underlined 5B8 will be erased, and the 0 in front of the 3A0 can be erased. In addition, the zeros in the middle, for the 4th, 5th, and 6th group, which are all zeros, and all zeros, these can be represented by 2 consecutive colons. So therefore, it would look like this, where the 0 in front of the 5B8 is removed, the 0 in front of the 3A0 is removed, and also between the groups of 4, 5, and 6, which are all 0, these can be changed into this type of a format. IPv6 addresses that are frequently used, we start off with the unspecified address. This address has an IP address that is all zeros. All 128 bits are zeros. That's why we have 2 colons representing that. And then we have a /128, which means that all 128 bits of the subnet mask are 1. This is used as an unspecified IPv6 address. In IPv4, this would be equivalent to 0.0.0.0/32, where all bits in the IP address are 0 and all bits in the subnet mask are all 1s, represented right here. For a default route, we use this notation where all bits in the IP address are all 0, and the /0 represents that all bits in the subnet mask are also all 0. And this is used as a default route in routing tables. This would be equivalent to the IPv4 address of 0.0.0.0/0. Also, there is IPv4 mapped to IPv6 addresses. And you can see that the way that the notation is done is right down here. Now, there are few exceptions that do apply. These are the references that I used, and I recommend them to you. Thank you.